Greetings folks and welcome to the Master Machines channel. Today we are talking about setting pinion angle. This is not a very complicated subject here, although it can be a little bit intimidating for the layman. And there is some specialty equipment involved. You're going to need some sort of angle meter. In my case, we're using an electronic angle gauge or angle finder. This guy right here. It's really nothing fancy. You turn it on, you zero it out, and you measure angle. So we'll just go through this real quick. There's some general specifications we're going to follow on pinion angle, but the idea here is to not have a significantly different angle from your transmission to your drive shaft than you do from your drive shaft to your differential. And the reason is because we're trying to cancel the harmonics of the universal joint. So universal joint kind of inherently has like a bind as it goes around, just because of the nature of the way that it works. So the idea is you want to cancel out that binding vibration with the other joint. So you're looking for equal but opposite working angles on the drive shaft. The hardest part of this task is finding a good surface on a transmission or on the diff to get a reading. Obviously, we're dealing with like rough castings here, and there's not always going to be like a perfectly parallel plane on the case that is representative of the pinion, the angle that the pinion is, or the angle that the output shaft of the transmission is. You kind of got to find a surface that you like to match that number and just go with it. But this really isn't that critical of an angle here, okay? We're going to get it within the lines of sanity, but as long as we're close, then everything is going to work just like it should. So general specifications that we're going to be shooting for is no more than 4 degrees on any one working angle. Personally, I want to shoot for under 2, but that's not always achievable. A lot of that's going to come down to your ride height and a lot of other things. Now, if you're working on like a factory car, if your transmission is a factory transmission in the factory location with a factory crossmember and you got a stock diff, then you're not going to have much to do here. If you were to lower your car a little bit or change your ride height slightly, you really don't even have to worry about this in theory, because whatever change is happening at the angle to the transmission is also going to equally happen at the differential. So a simple change in ride height, there's no reason to go and rework your working angles. But if you're dealing with an engine swap, transmission swap, differential swap vehicle like mine, which has all those things, then this is something that you have to consider. So I'm going to show you the angles, the spots that I used on mine just real quick. It's not easy to see down there, but I'll just show you real quick how I used my angle gauge. The main thing we want to remember with the angle gauge is we want to keep it facing the same direction during all the tests, so we don't end up polarizing the reading or getting the opposite reading of what we want. Another general spec that we're going to try to follow here, in addition to the under 4 degree rule at each working angle, is the two angles really need to be within half a degree of each other. So we might have over 3 degrees of working angle at the transmission to drive shaft, and that's borderline. That's a little more than we want, but as long as the other angle at the differential is within a half a degree of that, then we should still get sufficient canceling to eliminate any sort of driveline vibration. All right, y'all, so I got a turbo 400 transmission here. Now, this thing's kind of lousy. I'm not going to lie to you guys. It's real all over the place. I don't trust it a whole lot, but I think it'll get us within a half a degree of reality. So I like this ledge right here. To me, that's nice and flat. I can put my tool on it. I can get a reading. We got 1.7 there. I believe that probably coincides pretty well with the angle of the output shaft. If you could get on the end of the cap, that would be the perfect spot, because that is literally going to be your angle, but I can't because mine's kind of recessed down. Anyway, so that is the spot I like. You just kind of pick one and you just got to believe in it after that. And then of course, drive shaft's real easy. We're just going to stick it to the drive shaft, pointing straight at the ground. Get our second reading, which is real low. I'm not sure if the camera's going to pick it up because lighting. It's like 0.2, 0.3. And then on the differential, I have a forward 8.8. I'm going to go just flush along the back of the flange, and that's a really good spot to read it. So those are the spots I chose, and that's how we're moving forward. Another thing, working angles have to be measured at ride height. Right now I have the car up on jack stands, So it is not level to the ground, but that does not matter at all here. You do not have to have the car on a level surface to measure your driveline angles, but you do have to have the axle completely compressed at ride height from the bottom of the tire. So your suspension's compressed, the axle is the same distance from the body as it will be sitting on the ground. And so that's how we have this here. So the transmission is pointing upward in the rear, as you can see by my little arrow here, 1.6 degrees. The drive shaft is also higher in the back, 0.3 degrees. That's because I have the back of the car all jacked up. And the differential is actually pointing downward in the rear. So the pinion is pointing upward and the drive shaft is pointing upward. So what we're gonna do here is, since these two are pointing the same direction, we're going to subtract these numbers. So 1.6 minus 0.3 is going to give us a working angle of 1.3 degrees. Because they're going the same direction, they do not compound. You're going to subtract. The drive shaft and the diff are going opposite angles, so we're going to add these numbers together. So that's going to give us a working angle of 3.9 degrees. Now, that's too much by a lot. Like our number is low here. We need these two numbers. We need this and this to be within 0.5 degrees. All right. Also, 3.9 is just pushing it to too much of a working angle anyway. So the way we're going to fix this is by adjusting our ladder bars to lower the nose of the pinion. So it's going to lower this number, but it's going to increase this number because we're going to be lowering this end of the prop shaft as the pinion rolls down, because the pinion's sticking up off the axis of the axle housing itself. So as it comes down, it's going to lower, which is going to increase this number, bringing these two closer together. So as I make these adjustments, these two will get closer and closer together, and it looks like we got to go a pretty good way. So let's hope that we can get all the adjustment we need without having any interference with any other components. I do have an adjustable ladder bar, so this should be pretty straightforward. If you had a situation where your transmission was facing upward like that, your drive shaft was perfectly level, and then your diff was facing downward, that is not what you want. So these angles are not opposite. They're going the same way. You will have a problem with that. You have to have equal working angles, but opposite angles. So this is no good. You would have to turn that diff to face upward so that you really what you want is, this is an exaggeration, but you want a Z. You should have a Z so that you have these two angles are opposite to each other. You don't want that. That's no good. That's bad. But I'm really just trying to make sure that number's going down, so I'm just working these adjustments right here. Uh-oh. Wrong way. Oh, shit. There it goes. All right, so we lowered it down quite a bit there. Let's go ahead and get another measurement and see what our angle's at now. We're gonna have to get all three readings again because they should all have changed. All right, so after a little bit of trial and error and just taking some measurements, what we got is 2.2 degrees on the trans and 2.2 on the diff for working angles of 2.2 and 2.2. So we are dead nuts even on the working angles. They are opposite. This one's going down, this one's going up. So you can see the trans is still pointing high in the back because, of course, I haven't. The way you would change this angle is by shimming your transmission would be the first thing you would try. That's the harder thing to do. On cars with adjustable arms, this is definitely the angle you're going to get the most adjustment out of. So couldn't be happier with how this went. We got excellent working angles. We're equal and opposite, and everything went really good. I mean, honestly, that's perfect. 2.2 is a great number to have. You don't want to have zero working angle because it will cause premature wear of the U-joint. If the U-joint is at an angle, you'll have the needle bearings and it will be rotating, and they'll be like distributing the load more evenly and kind of moving, like they'll just be rotating as you move, like it makes things spin. So when you have zero angle, so if you just had a perfectly straight transmission, perfectly straight drive shaft into a perfectly straight pinion, you would wear out just a certain set of needles in the needle bearing pack inside the cap of the U-joint. So we don't want nothing, we don't want too much, we want equal and opposite, and that is how you set pinion angle. So here's where we're at now. Baby, I got the dash installed. We got our gauges up here. I gotta figure out how to configure these gauges. It's not super intuitive. Big bump buttons. Listen to this. Brake. Now listen to this. Brake on. Hit the bump. It just releases it for 1/30th of a second. This is how I got the bump box set up. There's a small little hobby timer. It's really pretty cool. So I'm gonna climb in. All right. So you hit the button and this just sends power to the timer, powers it on. And when it powers on, it grounds the relay. So you can program this thing any number of ways. So there's like a program on here. So actually you have to get this little programmer. It's just like a little computer chip. And it's got some wires that I just kind of left exposed. You have to jumper to these two wires here. And then you can hook up to the special Wi-Fi on the laptop. These things are really cool. So it was like $20 or less for this little hobby timer. You also got to buy the damn programmer, which is another 20 bucks cheaper. So you're out probably 40 bucks for the two. But this thing does so much. Like there's so many uses you could have for this thing. It can go like, it can like pause, turn a load off for 1/30th of a second. If you were trying to set up like turn signals in a car you made from scratch, or like honestly, like I don't know if I'm gonna get mine and this car working like I want them to, you could just get two of those things and have your, like it works like a flasher. You could just program it to just flash on and off at a certain speed, whatever speed you want, honestly. But you can do that. You can set it to delay, like as soon as it gets power, it could wait a certain amount of time before it turns on a load. You could have two triggers that do different things. It's really like, it gets pretty thick, pretty fast, like researching how to program this thing. And now I got it all working. So the bump box is good to go. Trans brake kicks on. I have the car back on the ground now because after I got the pinion angle all sorted out, I wanted to get on the ground anyway. But I was able to start it up earlier, put it in drive, put it in reverse. It clunks into gear. I pushed the brake and made sure it held the car. This red light's my oil pressure warning indicator. It's just a dummy switch that's on the engine. Whenever it drops low, the light will come on. Obviously the engine's not running, so it's low. So that'll just be a little warning for me. I don't have an analog sensor for oil pressure right now. I might add that later, have it up on my gauge, my little electronic gauge maybe later. But anyway, that's for another day. So today what I'm working on is I'm starting to fab up the downpipe for the turbo. We're gonna do it just like we did on Goldie version 1 and Ursula. Both those cars we just ran a straight open dump pipe down to the ground. I like doing that because it's short, which is good because race car. It's still blowing all the exhaust out of Trouble's way, but it's a little less obnoxious than like a hood exit or a fender exit. I'd love to do a cool exit like that. I think they're fun, but it's not practical at all. They're just so loud, and I don't know. I'm not really crazy about the idea. If you got a hood exit, then you got to worry about rainwater or whatever. Like it seems a little unnecessary. So we're gonna just dump it straight down to the ground. I'd like to at some point put full exhaust in the car, like not full, like a full pipe, not like a muffler or anything, but I'd like to run a pipe all the way out of the back, but that'll be for another day. But so what I'm doing here is I got my pipe just up here on the table, and I'm using my handheld bandsaw. My little Rockstar is helping me cut through it. And what I try to accomplish is like each cut, I don't want to be really any more than like 11 degrees. I feel like 11 or 12 degrees is kind of as high as you want to go before you start to begin dealing with ovals instead of circles. When you're cutting at a certain angle, you're going to get a lot more of an oblong hole. It makes it a little harder to weld. It seems to be working out. I'm just freehanding it. I thought about doing this at the shop, but it's just such a ruckus to get everything there, and I don't like the welder we have at the shop either. So we're going to just keep trucking along here. So just going to dump it down right in front of the wastegate there, and looks like I pretty much just have one more long pipe to cut. I think my last little angle is pointing straight through that hole, so we should be good after that. But my strategy is try to keep the cuts under 11 degrees. But other than that, I'm just literally eyeballing it. And I'll just cut a piece, just kind of think like, I probably need a hard angle here and this left angle there, and I'll cut a piece, and then I'll kind of put it on here and just index it in a way that seems like it's a good path, put a couple marks on it, tack weld it, and on to the next piece. All right, and there we have our downpipe. Pretty easy stuff. So we're just gonna fully weld that B up, and then we'll have an exhaust for the Z. I'll just need to weld an O2 sensor bung for the wideband. And boy, that'll be one less thing off the list. All right, exhaust pipe is done. It looks, man, that sucks right there. That sucks right there. This one was all right. This one was okay. Ah, big blobby bastard. The gaps were just a little funky. I don't care. Y'all know me. I wish it was better. I'll weep about it later, but it's done. It runs all the way down, exits at the bottom. Welded the O2 sensor bung on. That went just fine. And now we got the wideband on and reading. And you know, from up here, it looks okay. Well, I just ran the engine, so I got the radiator hoses clamped on. Look at this level of stupidity here. My previous video, I said I hadn't put clamps on here yet because I wanted to get decent clamps instead of the extra long, stupid part store ones. Well, look at me. That ended up being all I have because I never went and got the right clamps. So anyway, we're gonna have to put some decent clamps on this at some point. I also have like an extension down here to the radiator because it was just pulled a little tighter than I like. Anyway, got these hoses on, filled the system up full of some water, and immediately I found a leak. Water pump's leaking. This is the water pump. This is the one that came on this engine. I took a risk on it, and it's just dripping out of the weep hole at a steady pace. So we are gonna be having to do a water pump on this damn thing. But still, it was leaking slow enough. I was able to still fill the radiator and run her up to operating temp, and kind of just actually let it warm up fully, you know, burn the crud off of the exhaust and, you know, get the oil hot, and everything felt pretty good. Went into gear again. You know, I did that the other day, but everything feels good there. So that's a pretty important thing to establish, that we can get the engine hot with water in it without anything weird happening, except obviously an annoying little leak from the water pump. The engine ran really good. I got a nice idle speed on it, but whenever the fan kicked on at 190 degrees, it stalled the engine because all the AFR started going really lean. So that is an indication of a dead time problem when electrical loads change your fueling. So I am going to have to mess with my dead time charts. I got the dead time numbers from Hunter Tuned when I got the injectors, but he does them in milliseconds, whereas the Megasquirt wants percentage of change from the ideal battery voltage value. So you kind of set your 0, or really like your 100% is at 13.2 volts is usually what you're going to set your standard to. And Megasquirt wants to know at 14 volts what percentage of fuel it needs to take away, and below 13.2 volts what percentage it needs to add to supplement. So when those numbers are off, you start to have weird issues anytime the electrical loads of the engine change or the system voltage changes, and this is definitely one of those cases. So we do have to dial in the dead times, but I got to get this water pump taken care of, and so I'm going to go ahead and tear it off tonight, and then tomorrow I'll put it back on. All right, got the culprit off, the damn water pump. I'm not sure if this failure was pre-existing because the engine was in pretty bad shape when I bought it, or if it happened from sandblasting it or something I did along the way. I don't know. It was probably already toast. But I got it all tore apart here. It took me about 30 minutes, and I know so many of you guys are just face palming me right now, like, damn, you couldn't just spend the 80 bucks on a new pump. And, you know, hindsight's always 20/20. I wish I would have now that I know it's bad, but this is what I'm about. My labor is free. Like, I have the best situation possible here because my labor costs $0. So yeah, it would have been nice to foresee this failure and buy a pump, and I would have done it if I knew, because I don't love taking shit apart I just put back together. But man, I could have saved 80 bucks, you know, and to me, that's pretty good savings. I got the intercooler out tonight also, so I can start hacking it apart. So that's all, guys. I'm gonna try to get all you guys up to speed before the date of IFO. It is Sunday right now, 1 week until import face-off. I'll tell you right now, the car's running. I got it moving around, but there's a lot of tuning that needs to get done to get this thing dialed in. At this point, I'm not sure what class we're even gonna be able to be competitive in, because the car is very untested. It's been raining like crazy here in Texas, so I'm getting few opportunities to actually drive it. I'm gonna work on that this week. There's gonna be one more video coming at you before Sunday this weekend because I want everything to be real time going into the event. So keep an eye out on that, and we'll see you in a couple of days.